All right, another scary graph reading problem, right? A radio wave with a wavelength of lambda is incident on a conductor. The graph shows the variation of the wavelength of the maximum distance d traveled inside the conductor. So this is how far into the conductor it goes. This is the wavelength. And I guess the bigger the wavelength, the farther it goes in. So suggest why it is unlikely that the relationship between d and lambda is linear. Linear means a straight line, right? So if it is linear, you can draw a straight line through all the error bars. So talk about whether that's possible or not. You might even take your ruler, because you will have a ruler for the test, and see whether you can, right? Okay. Yeah, very good. And then the next question here says, find the fractional uncertainty in d and the percent uncertainty in d squared, right? For lambda is 5 times 10 to the 5th. So let's take a look at that one. That one's this guy right here. Okay. We want the fractional uncertainty in d. Uncertainty of d, right? And the percent uncertainty in d squared, right? So there's two different things, right? Percent of d squared, right? So take a look at that. What you want to do is you want to read this value, read what that is, right? Okay, and so the fractional uncertainty is going to be the size of the error bar. So the error bar does this, right? So read this distance here. Just one of them, not from the top to the bottom, just one of them, right? And it's going to be that distance. I'll call that one A, right? A divided by D, whatever that D is, right? So read the graph right here, whatever that is, okay? And the graph is, of course, an IB graph, so they make it hard to read. So read what that graph is and divide the size of this error bar by what the value of the graph is. It looks like it's closer to 4 than 0.4 than 0.2, certainly than 0.3 maybe. I don't know, maybe it's, I don't know. You'll have to read the graph, okay? Then the percent uncertainty in d squared, right? This is going to be a certain number, right? So let's say maybe it's 0.12 or something like that, which it's not 0.12, okay? For d squared is just d times d, right? So remember when you multiply two numbers together, you add the fractional uncertainty. So it's going to be this plus this will be the uncertainty of d squared, right? You just add it or multiply this by 2. But don't forget to turn it into a percent, okay? Because they want a percent for that answer. All right, and then the final page here, they are saying what are the fundamental SI units of the constant? Well, our fundamental SI units are meters, kilograms, seconds, right? So we're talking about meters here, even though it's like 10 to the 5th meters, right? And d squared is how far into the notice it's centimeters, but the fundamental unit is meters, right? So what are the units if d is in meters? What are the fundamental units of d squared? Because d squared has this, A has got the same units as d squared, right? So the fundamental units are meters. What are the units of that squared, right? I can't do any more without telling you. Now notice that B is multiplied by lambda, which is already meters, right? So d squared has some particular units, right? Okay, that's going to equal blank times meters. Okay, this is really pretty basic, but there it is, right? And d squared, d is in meters, right? Okay, yeah. Then it says determine the distance traveled inside the conductor by very high frequency. Well, high frequency is small wavelength, right? So what you want to look at is you want to find the y-intercept of this thing, right? So when lambda is 0, basically, okay, because they say very high frequency. How high? Very high, right? Okay, so when that, if d squared is equal to a plus b times, God, I can't even draw lambda. I drew a y instead. B times lambda, right? Okay, as lambda gets really, really small, this term goes away, and so d squared equals a, right? So this is a there, right? This is the, oh yeah, there we go, this same question here. Okay, so d squared is equal to a plus b times lambda, right? As lambda gets really small, d squared is going to equal a, right? So if d squared equals 0.04 times 10 to the minus 4. What does D equal? Simple math there. Yeah? Yeah? I think you need to make an argument about the lambda, right? As the frequency gets very high, the wavelength goes away. And so use this. That's probably the first mark, right? Second mark is just do the math. Okay? Again, I think I've said all the words I need to say about that.